phase angle is the angle between the voltage we apply and the current, our reference vector. So we can use tan phi is the opposite, which is VL minus VC, over the adjacent, which is VR. Now all those terms have got I in them, IXL, IXC, IR, so well, I'll put them in there. IXL minus IXC over IR, ding, 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 cancel out. So phi is tan to the minus 1 of XL minus XC over R. The phase angle between the voltage and current. Really interesting thing is, remember that we talked about power a few minutes ago, and I had power for our DC circuit was VI. With an AC circuit, the power can be expressed as the magnitude of V, the magnitude of I, cos phi. The phase angle, which suggests that if we have certain phase angles, we're going to get more power out of the circuit than at other phase angles. And in fact, should the phase angle be 90 degrees between the voltage and current, then the power dissipated in the circuit should be 0. So if we're using a lot of electricity, big factory, let's suppose this is the production of aluminium from bauxite in the South Island, using fantastic amounts of electricity, it's very important that you have the right phase angle between your voltage and current, or else you're not going to get the optimum amount of power extracted from your circuit. The last bit of the sub-question is resonant frequency. And I think we'll have a break. So resonant frequency of this circuit, we bring in reactance. I better write that one down. Z, this is the equation we just had. Z equals, what was it? XL minus XC squared plus R squared. The impedance of the circuit. Now, at the resonant frequency, XL and XC are equal. So at resonance, XL equals XC. Well, if XL equals XC, then that implies that Z equals the square root of R squared, which is R. So suddenly, the circuit is purely resistive. It's as if the capacitor and the inductor are no longer in the circuit. They've just disappeared to all intents and purposes. So what is the resonant frequency? Well, as I said a minute or two ago, XL equals omega L, which equals 2 pi FL, and XC equals omega, I've done it again, 1 over omega C, which equals 1 over 2 pi F. See? And at resonance, these two things are equal. So 2 pi FL equals 1 over 2 pi FC. And if you just want to rearrange that, then you will get that implies F equals 1 over 2 pi times the square root of LC. There's our result. Very important equation. And at that, when the frequency is given by that, then it's as if the reactance of the inductor and the capacitor are cancelled out. This term disappears, and the impedance is purely resistive. So maximum current flows. And we can make use of that in developing tuned circuits. Do you remember when we were doing this, I told you a little bit about the crystal receiver, how you can make a little radio if you want to, using a tuned circuit. Anybody remember that? Anybody come to the board and draw a circuit diagram of a crystal receiver, the old crystal receiver? All right, well, what would you need? You want to build a crystal radio, what do you need to buy? Big coil of wire. You want a big, long antenna. Let's say 100 feet of wire, 20, 30 meters of wire. So that's going to be our antenna, and we just string it across outside, across a field or something, keep it off the ground, hope it's in the right direction. So that's our antenna. Then we need a tuned circuit. So we're going to get ourselves a piece of cardboard tube, something like a kitchen roll tube, wind insulated wire around it. About 100 turns will do the trick for medium wave. On the other end of that, we connect it to the ground, right into the soil. Now what's going to happen is electromagnetic radiation hits this big length of wire, and it induces electricity in the wire, so we get electricity flowing up and down the wire in synchronism with the radiation. But, of course, there are lots of different signals hitting that wire, different frequencies. So we want to tune into one, we want to pick up a certain station. So we need to build a tuned circuit. This time we'll use a variable capacitor. Okay, so as we vary that capacitance, here's the formula, with varying C, so we're varying F. So there's your L, and there's your C, and when you have the right situation, you've got the right resonant frequency, we want the resonant frequency to be the frequency of the wave that we try to pick up. All the other frequencies will go straight down to the ground, except the resonant frequency. So now we've tuned in on one particular station. But it's still a high frequency signal whose average value is 0. That's a wave going up and down, its average is 0. So now we stick a diode in there. A diode lets electricity pass in one direction, not in the other. Well, you can really get away with that if you have one of those old-fashioned earpieces or something and your headphones, and you stick it on there, then you'll hear music or whatever. It's not very selective. In fact, you'll be lucky to be able to tune across 2 stations. You'll probably only be able to hit on one particular station. But it's basically tuning out all the other signals except the one you want, converting that signal that has an average voltage of 0 into one that has a positive average voltage, and feeding it through headphones. You should also put a capacitor across there, but I've built these things without a capacitor in there, and they still work. It picks up some residual capacitance normally. That's a little crystal receiver. Of course, remember I told you that, like in the prison camps in the Second World War and things, they didn't have things like diodes. In fact, semiconductor diodes, well, there were some solid-state diodes, but by and large, diodes were little valve-type things in those days. They didn't have those. But they found that if you had a piece of coke and a needle, and you prodded the needle into the coke and you kept playing around with it, sometimes you could get a sort of semiconductor-like property where it would act as a diode. So a piece of coke, coal type thing, and a needle. And that's how they implemented the rest you can make. To make your coil, you can make your capacitor, you can make your headphones. Okay, the point to that is that this tuned circuit has a certain resonant frequency, and it's given by the equation. So it's not very selective, that circuit. There's no gain in it, so that's why the aerial, the antenna, has got to be so long to induce sufficient voltage into the circuit to turn on that diode